Hi, good morning everyone. Welcome to today's webinar brought to you by Center for Precipitation of Masa University. Thank you for joining us today's webinar. My name is Siti Azwani. I am a physics lecturer from Center for Precipitation Studies of Masa University. I will be the moderator for today's sharing session entitled Discuss Physics in Type 111. Okay, not 112. I'm this session and I'm pleased to introduce today's speaker. Today we have two speakers. Both of them are from Center for Pre-University Studies. Let me introduce a little bit about okay, we have our first speaker, Dr. Muhammad Hilmi bin Abdul Mubin. Currently, he is a physics lecturer, Center for Pre-Research at Masa University. He is from PhD holder from University Technology Malaysia with the aim in material physics. He is specializing in nanomaterials. He has 7 years experience in research. He already published an article on ISR and support and attended some of international conference. Today, Dr. Muhammad will share to us about the nanomaterial. Okay. Without further ado, I would like to invite to Dr. Muhammad Hani, share their knowledge regarding to the nanomaterial. Me on the screen to Dr. Muhammad.
Okay, thank you very much, Madam Siti Azwani, for the nice introduction. So, my name is Muhammad Helmi bin Abdul Mubin, and I'm one of the physics lecturer in Masa University, especially under Center for Pre-University Studies. So, for today, I would like to having some sharing session with all the audience, with all the viewers, regarding the one of the highly demanding material and very interesting field, okay, which is the nanomaterial. So I hope by the end of this session, all of the audience can have some basic knowledge, okay, some general ideas what is nanomaterial, right? Why the nanomaterial is one of the interesting field that we can study, and then what kind of application, okay, that we can use the nanomaterial in our daily life. And last but not least, I will share about how can we create it, or in other terms that researcher use is how can we synthesize the nanomaterial. So for the introduction, what is exactly the nanomaterial? Okay, actually the nanomaterial have been invented a long time ago during the era of modern physics. Okay, Albert Einstein, quantum physics, right? So during that time, the nanomaterial already been invented. So there is some quote by the researcher. Okay, the nanomaterial, which is we use the small object. The object is actually the material itself in order to solve a biggest problem. So you can see that this kind of very small object can solve the big problem, especially in our daily life. And also from Greek words, the nano means nanos or dwarf. Dwarf referring to something smaller. So something smaller can bring the big impact, right? And then in the field of nanomaterial is a study development of material where it aims to control, to control and design what? To design specifically in the size of 1 to 100 nanometers. Okay, if you see there is a some of the product claim that they are having some nano material inside, nano white, nano skin, whatever nano inside, meaning that the size is ranging from 1 to 100 nanometers. Okay, you know that in our world, okay, we are divided into 3 category of sizes. All right, if you see here, we have the first category is macro. Macro is bigger. So that's mean you can see with our naked eye. All right. For example, tree, car, football, whatever, which is bigger that we can see with our naked eye, to the smallest thing that we can see, which is the size of a flea. Okay, which is 1 millimeter. So we can see we don't need any material or with any device in order for us to see the macro, this macro size. Okay, and then we will go to micro sizes. Okay, micro sizes already we cannot see with our naked eye. All right, so that means we need to use a certain device in order for us to see and to measure the size of micro. For example, the diameter of human hair, the red blood cell, okay, and which is the 7 micrometer. So that means we need to use a certain device to in order for us to measure to see which is the microscope. And then we will go to the category of nanomaterial. All right, so nanomaterial, of course, we cannot see with our naked eye, and also we cannot use whatever device to measure from micro category. Okay, so that means we have another special method or special technique in order for us to measure, to see, all right, to see the virus, to see the nanoparticle of nanomaterial, which is the titanium dioxide, the thickness of strand of DNA, which is 2 nanometer. So we are using electron microscope, which is one of the special device, okay, in order for us to see the nanomaterial. Okay, so as you know, nanomaterial is very small, so it divided into 3 categories. Right, the first category is the natural nanomaterial. Okay, so you know the natural nanomaterial is occurred naturally. All right, occurred naturally. For example, the dust particle, okay, the volcanic activities, cosmic dust in our space, all right, aerosol colloids, and also some of the chemical precipitation by bioassisted or biomass combustion. This is all the naturally occurred nanomaterial. It's not made by human. And then the second category is divided into 2. All right, so that's why I say that we have 3 categories of nanomaterial. So this man-made nanomaterial, all right, is made by scientists, made by pharmacists, made by engineers, made by researchers. All right, so this is man-made nanomaterial. But during the process of synthesis of this nanomaterial, it actually having some byproduct of nanomaterial. That byproduct is accidentally occurred. Okay, that is another category of nanomaterial. So if you see here, I show you some example of nanomaterial, which is ranging in terms of size and also in terms of shape. Okay, actually you can shape your nanomaterial into certain cases, certain kind of application. All right, we have nanotube, nano wire in the shape of nano wire. It's not a big wire. Okay, this is the nanomaterial wire. We have nano fiber, nano flower, nano sheet, and nano particle. Of course, all of this is actually different kind of shape. All right, shape and sizes. All right, so you will be wondered why we need to use nanomaterial. We have a lot of other material. Nanomaterial, even we cannot see with our naked eye. Why we need to use this one? So I will explain what is the advantages of using nanomaterial. Okay, the first one is faster. Faster in terms of what? In terms of sensitivity and also in terms of the response time, especially the sensor. Okay, and it lighter. Of course, this is nanomaterial. It lighter. All right, and also cheaper than bulk. Of course, it's cheaper, okay, than bulk material, and it can fit small spaces. You see, your laptop, your handphone, your desktop. During 10 years ago, the laptop, the desktop, the PC, all of that devices is very big, very thick. But nowadays, the size of a laptop is less than 1 kilogram. Okay, due to the chip inside the laptop, inside the devices, we use the very small nanomaterial. Okay, it can fit the small spaces that can light up, can bring some power in your PC, in your phone. Okay, and then high sensitivity, of course, it's very high sensitivity and having different kind of properties. Some of the engineers try to tailor, okay, tailor some kind of properties of nanoparticle according to their needs, to their application. For example, if you see the gold nanoparticle, bulk gold particle is in yellow color, gold color. Okay, but what happened when you create the gold nanoparticle, it having different kind of properties, okay, due to the size of that gold nanoparticle. Some of the gold nanoparticle in red, in light red, blood color, blue, light blue. All of these color, okay, all of these nanoparticle having different kind of property, okay, depending on the size. And the last large surface area to volume ratio is the keyword. This is the key why engineer want the nano material, okay? Because having large surface area to volume ratio, okay? This is where the sensitivity comes in, all right? The fast response times comes in, okay? Let me explain what actually is large surface area to volume ratio, okay? Let's see here, okay? If you see, we have one cube here, all right? One big cube. Let's say this is a particle. All right, each of the length is 4 centimeter. Let's say 4 centimeter, and then the total surface area for this cube, we have one cube, we have 6 surface area. 6 surface area times with the area become 96. Okay, but maintain the volume is 64. If you calculate the surface to volume ratio, we get 1.5. Okay, what about if this big cube we cut into 8 small cubes, meaning that one big particle we create into small particle, all right, which is the edge of the length for each length is 2 centimeter. You see, the total surface area become double, okay, become more. For example, 1 cubic we have 6 times with 8 cubes, time with the surface area of each of the cube become 192. Okay, still maintaining the total volume, but you see the total surface to volume ratio become double from 1.5 into 3. Okay, meaning that there is more surface area in contact with the environment. All right, what about if we crush into very small cubes? You see the total surface area become 384 while maintaining the volume, and it become the total surface area to volume ratio becomes 6. Okay, you see from 1.5 to 6. When we have a smaller particle, we increase the surface to volume ratio. So another example that you can easy to understand, for example, if you have the Panadol soluble, okay, what happens if you put the Panadol soluble and dissolve inside the water? It will take a certain times, correct? Yes, but what about if you crush the same tablet into powder and then you dissolve in the same amount of water? Of course, less time is needed. Okay, for example, from the big tablet 1 minute and then you will take almost 10 seconds, 20 seconds already fully dissolved. This is the highly sensitivity of nano material, which is having the size of nano and then more contact area. Okay, you have a more contact area. All right, so I hope you understand why the nanoparticle is very special. All right. Okay, now I will share what kind of application that we can use in our but without you realize you are using this nanomaterial in everyday life, in your daily life. Okay, for example, electronic devices, transistors, transformers, processor. You see, I just explained your laptop, your PC, your desktop. All of this material become smaller and smaller. Your laptop become lighter. Your laptop become very thin. Okay, it's easy for you to carry every day. You carry, okay, inside your bag. So meaning that electronic devices now we use the nanomaterial. During 10 years ago, the processor using very big processor. Nowadays, Core i7, you even use from 40 to 45 nanometer. Okay, it's very small, can light up and can boot up very fast. Okay, and then optoelectronic devices such as photodiode. All right, photodiode, solar cell. This is all sensitive to photon. Okay, and then we have memory devices such as hard disk, your hard disk. Okay, your pen drive, your random access memory, diskette, CD, all of this using the nano material. So that's why the CD becomes smaller. Okay, your pen drive become very small. Okay, and then the engineer use the nanomaterial in the wastewater treatment. You know that the behavior of nanomaterial is highly sensitive, so it can become the catalyst. So as a wastewater treatment, the engineer build up the photo catalyst sensitive to photon in order to degrade the impurity inside the water. Okay, especially in very polluted water. All right, and some of them are having the nanomaterial into the nano filter. For example, carbon nanotube become the nano filter. All right, from very polluted water become to the clean water. All right, and then we can use medicine. The pharmacists create the medicine in terms of nano sizes. All right, for us easy to swallow, and some of the particle of the medicine can easy to flow inside our blood vessel, so it become more efficient. Okay, the medicine become more efficient. And last but not least, I know, man, girls, you know, you will use all the skincare product, right? For example, your cleanser, your toner, essence, serum, especially the physical sunscreen. All of these skincare product having the nanomaterial. For example, the sunscreen, physical sunscreen, you're using the titanium dioxide, zinc oxide in order to protect your skin from sunlight, right? So why people create the nanomaterial? Because it's easy to absorb into your skin. Okay, so skincare product also we use the nanomaterial, right? So let me share with you, okay, there is how can we create the nanomaterial? How can you synthesize the nanomaterial? Okay, so I will share with you some general knowledge. Okay, we have three methods to synthesize of nanomaterial. We have three types, three general types of synthesize the nanomaterial. We have PVD, physical vapor deposition. We have CVD, chemical vapor deposition. We have CSD, chemical solution deposition. These three is the general type of how can we create the nanomaterial, and you will see this a lot. Researchers use this a lot. Okay, so I will explain you one by one. What is the PVD, CVD, CSD, and what is the mechanism behind it? How people use this technique. Okay, now we go to the PVD, physical vapor deposition. Okay, what actually is the physical vapor deposition? It's one type of top-down approach method. Okay, what is top-down approach? Top-down approach method meaning that from a bulk, from a bulk material, you create, you synthesize, you vaporize into small nanoparticle. This is we call as a top-down approach. Okay, so in PVD, it requires some ejection or it requires some vaporization of the physical material, which is your material, target material, for the atom, molecule, and condensation of the nucleation of the sum of this particle, some of this target material onto your substrate. Substrate can be your alumina substrate, can be your silicon wafer, can be some other membranes. Okay, this is all the material you're using to create a thin film. Okay, thin film of what? Thin film of nanomaterial. Okay, by using the PVD. But certain kind of technique we use, we will introduce certain kind of gases inside the chamber. Okay, inside the working space. All right. In order for us to enhance, to produce some plasma, plasma can enhance and react the deposition to form a new compound or enhance the rate of production of your material. Okay. What kind of material that we can use in PVD? Okay, what kind of material? All right, okay, we can use such as metal, ceramic, semiconductor, polymer, composite, etc. Many things can be used, okay, but must be in solid form. Okay, PVD, physical vapor deposition, must be in solid form. From solid, it will vaporize into the nano material or deposition material. Okay, as I said, we have a different kind of PVD. PVD is the general, okay, but we have a different types of PVD technique, physical vapor deposition technique, and all of these technique we must be done in very high vacuum. Okay, why we need the high vacuum? In order for us to decrease the impurity, to increase the purity, okay, to remove any contaminant, okay, any contaminant such as dust, whatever particle we don't want. So that means it can cut all the impurity, okay, in our material. Okay, for example, ranging from 10 to the power of -4 to 10 to the power of -5 millibar. This is very high vacuum. Okay, so let me explain. What is the mechanism behind this physical vapor deposition? Okay, you know that we have a different types of physical vapor deposition. So this means I will explain one by one. In here, I will show you only 4 types of physical vapor deposition. Okay, actually this 4 is very popular PVD that many researchers use. We have a lot more, but I will explain this 4. Okay, the first one is the thermal evaporation. So meaning that thermal evaporation is one of the PVD. So this means from the name itself, we use the thermal. Okay, we use the thermal in order to vaporize our sample into the substrate. If you see, this is the chamber. Okay, this chamber is under high vacuum. Okay, under high vacuum. If you see, we can put our sample into this crucible boot, or we call as a holder. Okay, this holder can be made of alumina, tungsten, whatever material, and then in the middle we put our sample target. So this sample target will be supplied by electron current. Okay, electron current, and it will be heat up to certain melting point of the material and will be vaporized to our substrate. Okay, substrate is here and form a new layer of nanomaterial. Okay, and then the second type is electron beam evaporation. So the concept is the same, the mechanism almost the same with thermal evaporation, but we are not using any thermal, but we are using electron beam to vaporize our sample target. You see here hot filament. Hot filament is not to use to hot or to heat our target. Okay, actually the hot filament is to produce the electron beam. Okay, while we produce the electron beam and then we have the focusing magnet in order to create the magnetic field to direct, to accelerate our electron beam, and then it will be deflected by the deflecting magnet to our target. Okay, and then this target will be heat up not by thermal but by electron beam and will be evaporate or vaporize to our substrate. You can gain the thin film. All right, your material. Okay, the third one is the magnetron sputtering. Okay, magnetron sputtering is quite special. Okay, it's not the same with electron beam, it's not the same with thermal, but in magnetron sputtering, we are using certain kind of gases. We will be introduced to these gases, especially argon gases. Okay, so what is the mechanism? Our target will be put at the cathode and the substrate will be put in the anode. And then this cathode and anode, and we will create the plasma or in the middle, okay, inside the chamber. So once the argon atom is flow inside the plasma, and then it will be ionized. Okay, this ionization, okay, will create the argon plus and also the secondary electron. So meaning that this argon plus actually it will be bombarded into our target or target material, and then one of the target material will be being vaporized into the substrate, and this will repeat. Okay, the argon plus will recombine back with the secondary electron, become argon atom, and it will be ionized back and become to argon plus and secondary electron. It will be repeated. Okay, until all the substrate having the thin layer of nanomaterial. According to our size, we can vary the size. Okay, by using the magnetron sputtering. And then last but not least, we have the pulse laser deposition. All right, so the pulse laser deposition, the mechanism is the same. Okay, we have the target, and then this target will be vaporized by the laser beam. Okay, the laser beam will be shoot onto our target and will create the laser plumes. Laser plumes is kind of terms we use when we having some kind of vaporize. Okay, vaporize our target, and we will see some certain kind of color. This is laser plumes. All right, and this vaporized material will go to our substrate. All right, this is all the mechanism of PVD or physical vapor deposition. Now let me explain about CVD. Okay, the second types of technique we can use, which is the chemical vapor deposition. So chemical vapor deposition also is one of the top-down approach method. Okay, so this is one of the coating technique. Okay, the coating technique to produce our layer of nanomaterial, but we use thermal. Okay, the process is thermally induced, and then we have some chemical reaction at the surface of our sample substrate. Like I said, substrate can be any material, can be silicon wafer, can be alumina, can be conic glass, can be soda lime glass, anything, but according to your needs. Okay, because we are introduced the thermal. Okay, the thermal is quite high, the temperature ranging from 600 degrees C to 11 to 1200 degrees C. It's very high. So all the needs is according to your sample material. And what is the advantages? It's easy to control the mixture gas. For example, if you are introduce some dopant inside, so meaning that you can easily mix the sample. Okay, if you from PVD, we are using the solid, right? We are using the solid material, but for CVD, we are using the gas material. So meaning that your nanomaterial particle actually is made from the gas. Okay, the gas will be vaporized inside, will be ionized. will being ionized. So our target or precursor used in the form of gases. All right, and we have a different type of CVD technique, the same with PVD and CVD also we have a different types. And the key major factor that you need to vary, okay, the parameters that very important in CVD, we have substrate material. What kind of material that you are using? Okay, for example, corning glass, soda lime. So according to your temperature, some of the temperature the substrate material cannot withstand, it will melt. So meaning that you must choose the parameter wisely. Okay, substrate material and substrate temperature. Okay, you are ranging the temperature from 600 to up to 11 to 1200 degrees C. The gas mixture you are using, if you are introduce some dopant, you are mixing the gas, and then the flow rate. Okay, the flow rate of that gas where you introduce inside the chamber. All right, so let's see the mechanism of chemical vapor deposition. Okay, like I said, we have a different types of CVD, but in here I only show the main or the major that people always use, researchers always use, which is we have three types. Okay, which is the first one is the conventional chemical vapor deposition, where this is the old school one. Okay, not so old school, but some nowadays the machine is already too sophisticated. Okay, the conventional one is where we have the furnace or we have your chamber, the working chamber, and then in the middle we put our sample, meaning that you are put your substrate in the middle. Okay, and then this chamber will be heat up to your operating temperature, which is ranging from 600, like I said, 300 to 11 to 1200 degrees C. Okay, once the temperature is reached, okay, and then the mixture gas of your material will be introduced inside. What happened is, once the gas is introduced inside, it will be ionized due to the high temperature. Okay, it will be ionized into ion, and then it will absorb to your sample and have some chemical reaction in order to stick or adhere the sample, the material onto your substrate. And then what, of course you don't want the byproduct, so this byproduct actually will dissolve back. Okay, the impurity will dissolve back and will go to the gas outlet. Okay, this is the mechanism of the CVD. Okay, the CVD. And then we have plasma enhanced CVD, which is you are introduce the plasma in order to reduce the working temperature to several hundred degrees C. So meaning that if you are using the plasma enhanced CVD, you can reduce up to 300 degrees C only. So meaning that you can use a variety of sample substrate. Okay, so meaning that some of the substrate we cannot use the conventional due to the high temperature. Okay, so this means you can use the plasma enhanced. Mechanism is the same with the conventional. Okay, and last but not least, we have the laser induced CVD. All right, so meaning that the gases will be induced by the laser ablation or the laser beam. Okay, we will shoot the laser onto our substrate and the gas will be ionized. Okay, so laser induced CVD is being used when some researcher want to have some pattern, layer pattern on the substrate, meaning that you can control the pattern by moving the laser. So by moving the laser, that spot of that laser is being ionized. The gas will be deposit. Okay, your sample target. All right, and then last but not least is the chemical solution deposition. All right, so PVD we use solid material, CVD we use the gaseous material, but CSD or the chemical solution deposition, we create the nanoparticle from the solution, from the chemical solution. Okay, it one of the kind is a coating or producing the nanoparticle technique, which involve the usage of chemical solution as your starting material, or we call as the precursor material. Why we need to use the CSD? Okay, because it's very cheap and easy to prepare. No need any special kind of environment you need to prepare. Normal lab also we can create the nanomaterial. Okay, and also it easily to control the stoichiometry ratio, especially the one who want to introduce some dopant. Okay, 10% magnesium, 20% bismuth, 10% nickel, meaning that you can control this stoichiometry easily. Okay, by using the solution. All right. you can just calculate the stoichiometry ratio and then introduce and dissolve into the solution. All right, and no need any sophisticated equipment. For example, PVD, you need very high-tech CVD, high-tech of equipment. But for CSD, no need to use all those kind of high-tech. Okay, you only need some solution, some chemicals, some hot plate, and also substrate. Very easy to prepare. Okay, and also yield very fast result and sample. You will yield the result of the material in the very fast time. Within an hour, you can get your result already. Okay, and also easily prepared in any surrounding. Okay, we don't need any high vacuum environment, we don't need any chamber, so that means easily be prepared in just ambient surrounding. All right, this is all the advantages of chemical solution deposition. Okay, so I will go to the mechanism. All right, the CSD also having some types of deposition. Okay, start of technique. Okay, I will show you in here 5 kind of popular technique we will use in the chemical solution deposition. Okay, the first one is deep coating. Okay, deep coating from the solution. All right, you are create your precursor solution and then you are dipping your substrate. Just dip your substrate inside the beaker into your solution and then you pull back. Okay, pull back and then all the coating material is coated into your substrate. Very easy. And then we have spin coating. Okay, from the solution you drop a few droplet of solution onto your substrate and then the substrate will be spin or rotate up to several thousand of rpm. Okay, to spread the solution become the thin layer and then the thin layer will be evaporized and then evaporate and then will create your nano material, thin film of nano material. And then we have co-precipitation. Okay, co-precipitation is actually from the solution you are creating the nanoparticle in terms of powder form. Okay, not thin film, in terms of powder form. Okay, from a solution you put some chemical in order to have some chemical precipitation at the bottom of the beaker and then you wash it and you filtrate. Okay, you filter the precipitation and then you dry, become dry powder of nanoparticles. Okay, and then we have auto combustion solvent, the same concept. Okay, the same concept but different kind of chemical is introduced. Okay, from solution you will create the nano particle. From solution you put some chemical or you call as a chelating agent. Chelating agent is used to strengthen the bonding between the particle. Okay, for example, if you introduce some doping, okay, you strengthen the bonding from the chelating agent. Okay, and then you will evaporate the solution and then it will combust. Okay, combust into nanoparticle. Last but not least, we have spray pyrolysis, which is from the solution, you create the solution and then you are using the atomizer to spray. Okay, there is a tiny droplet and then it will spread into the substrate under heat. Okay, under certain working temperature. Okay, meaning that your thin film or your nanomaterial will stick and adhere to your substrate. So I hope all of you already have some knowledge about the nanomaterial and thank you very much for your time. Okay, so have a nice day.
Thank you so much to Dr. Muhammad Hami for your sharing session. Very good and very interesting for that sharing session. Okay, I hope that audience got some of the able basic knowledge regarding the material, which is nanomaterial. Okay, let's continue. Okay, this is entitled Physics in Life Part 1. Okay, before proceeding to this next study session, okay, I would like to introduce a little bit okay, about uh, the second speaker. Okay, let me introduce to the second speaker, which is Dr. Nurhayati binti Muhammad. Okay, currently he is a physics lecturer at Center for Pre-University Studies of Malta University. Okay. She's a graduated PhD holder from University of Malaya in plasma. She has been more than 10 years experience, okay, in teaching experience with private and semi-government institutions. Okay, how about the research? Okay, she has been presented in local and abroad conferences. Okay, she's one of the members of the Fifth Asian World Group on Applied Plasma Science and Engineering APX in 2019. Okay, she will focusing okay, on this sharing session on plasma. Okay, without further ado, I would like to invite okay, second speaker okay, for the sharing session today. Okay, I would like to pass to Dr. Nurhayati Muhammad Nazir.
Okay, Assalamualaikum and very good morning. Thank you, Madam Azwani, for the introduction. Thank you, Dr. Helmi, for very good and very technical presentation just now. So basically, I will continue with a very light and moderate, not so technical kind of session this morning. So just now you have heard from Dr. Helmi based on nanomaterial, right? So hopefully you have had the idea of for those who are actually planning to continue their research, to continue their study for the postgraduate. So hopefully they have the idea of when you listen to the sharing session just now. Okay, so for my topic, I will continue just for some sort of sharing in terms of plasma. So I believe maybe this will be the first time of you listening to, heard of this plasma. So I bet some of you, when we say plasma, definitely we will think of blood plasma. Am I right? Okay, but it's not only that. When we talk about plasma, okay, so what is actually plasma? Okay, so if you happen to remember that you have learned during secondary school, whereby you have in terms of the topic of matter, right, which is you have solid, liquid, and also gas. Okay, but your teacher maybe miss out one part, which is the plasma. So plasma is the fourth state of matter, which means after you have the solid, you have the liquid, and as well as you have the gas. But after that, what happened to the gas? Is that all the process that we have? Definitely, the answer is no. Okay, so plasma is the next type or the next state of matter, whereby as you have, in order to change the solid to the liquid, from liquid to the gas, definitely it involves certain processes. Am I right? Okay, so if you still remember, how do you turn solid to liquid? How do you turn liquid to the gas? Definitely it's through heating process, right? Okay, as you provide heat or as you heat certain material or certain solid, definitely the structure of the material will change, right? So as the material, the structure of the material change, definitely the state of matter also change. So this is what happened. Okay, as you have a material, as you have a solid, as you heat that material or as you heat that solid, definitely the structure of the atoms will change and will turn into liquid, right? Very good. Okay, and after that, when still continue processing of giving heat or the heating process, definitely it will turn into gas. But as you were told before, you just stop until gas itself. But if you actually increase the temperature of that material, it has the ability to change into another state, which is what we call plasma. Okay, so these plasma, it can, where or when do we normally see this, right? So basically, because this thing is not occurring, not able to see, exactly, you're not able to see or not able to observe that kind of thing. Okay, like as you have the solid, the liquid and gas, we are able to observe, we are able to produce that matter. Somehow this plasma is actually occurring in our space. When you have for the sun, the environment of the sun, it's definitely consists of a lot of plasma. Okay, so basically, what is this plasma? Is we can say that to be specific, we can say that it is ionized gas, which means that the third state of matter, you have the gas, but somehow as you increase the temperature, so it will become ionized. Right, as it becomes ionized, so it will consist of various of species. As you can see, it will consist of neutral atoms and molecules that we call photons, okay, electrons and free radicals, excited atoms and molecules, reactive oxygen species. So basically, different experiment, different approach that we have, definitely they have different kind of species that they are looking for. Like, depends on what kind of applications that you want. So basically we will actually focus on what kind of species that you are actually planning to have. Okay, so again, when you plan to have, or when you plan to use this plasma, definitely you should know that you are dealing with ionized gas. And how do you actually produce the ionized gas is by giving out or by providing high temperature. Okay, so which is up to more than certain voltage also required. Okay, whereby you have high voltage as well as also the high temperature. Okay, now for this today's session, definitely I will go into technical about this plasma generation. I mean, definitely we have a lot of various or thousands of setups or that we have, I mean, in order to actually to generate the plasma itself. Okay, but somehow today I will just want to focus more in terms of more or less like the brief introductions of the plasma itself. Okay, as I mentioned just now, when you talk about plasma, it's an ionized gas, right? When you want to ionize the gas, definitely it requires high temperature. Okay, so for these plasma, you can actually divide into two parts, which is the high temperature plasma and low temperature plasma. Definitely for my field, I am more on the low temperature. I will say I'm more like a low temperature kind of person, not the high temperature kind of person. Okay, so when you talk about these, so definitely for plasma, we have these two fields. Those fields, when you have plasma, so these people, these researchers, they are actually work on high temperature, like fusion, like you have what do you call that, nuclear reactor, that kind of thing. Okay, so that will be in terms of the high temperature. And for the low temperature, it's more or less like we are trying to produce the plasma at temperature kind of ambience. Okay, so now what is this high temperature plasma? Definitely from the wording itself, it tells you straight away, right? I mean, in terms of, definitely we are referring to the temperature. Okay, so but more or less this high temperature plasma will refer to the equilibrium system, which means that if you have an ionized gas, whereby we consider that they have electrons and the heavy particles at the same temperature. Okay, so basically those who are actually dealing with high temperature, so we will have some sort of equilibrium plasma system. Okay, and they are in thermal equilibrium with each other. All the particles, all the reactions, all the species, all the electrons, whatever species that we have inside the plasma, so they are actually at the same or at the equilibrium temperature. Okay, but what is the low temperature plasma? Again, when you talk about low temperature, so we are talking about, definitely we are referring to the temperature itself. Okay, because when you deal with high temperature, so normally you will have very high temperature, and definitely we cannot deal with what do you call that, the application would be very limited. I mean, limited in a way that if you are actually talking about the biomedical science, the medical part, in terms of all the applications which relates to the living thing, definitely it's very hard to work with, because high temperature normally it will involve all the industrial applications. Okay, now for this low temperature, again it's non-equilibrium system, whereby the electron energies of a few electron volt to 10 electron volt with ionization degrees. And again, we have for this low temperature, definitely the temperature will reach about the environment temperature or the room temperature itself. Now, what is the importance of having this room temperature? So again, basically it depends, or it is because of the applications itself. What is the needs of having low temperature? Okay, what is the usefulness of when you have a plasma at low temperature? What are more or less the applications? Okay, on the application side. Okay, so again, the aim is, in order to produce the plasma, so what you need to do is you have to provide heat. All right, or more or less, or this would be, what do you call that, a fundamental setup. Okay, a fundamental setup of how are you going to get the plasma. Okay, so the important thing that you have to have here is Here we call it a dielectric barrier discharge. Okay, why it's considered as a dielectric barrier discharge? Because in between of this electrode, you have the ground electrode, you have the voltage, high voltage electrode. Okay, so here in between you have the discharge, and this dielectric barrier is to actually to ensure that there is no arcing produced in between the processes. Okay, now why it's the importance is just to ensure that once you have the plasma, definitely you will observe the plasma in between the two electrodes. Okay, so you have the high voltage electrode, the ground electrode, definitely you have to have two. Okay, so but again, as you talk about this plasma, we have a lot of setups, we have a lot of what kind of what do you call that, the distribution or the configurations of the setup itself. But this one is as a general one. Okay, as a starting point, if you want to plan, or if you plan to generate a plasma, definitely you have to have at least, I mean, you have, the important thing is to have the electrode. Okay, you have to have the electrode, the high voltage electrode, another one is the ground electrode, and not to forget the dielectric barrier. So these dielectric barrier, again, the importance of having the dielectric barrier is to ensure that there is no arcing between. Arcing means there's a conductive path that been produced in between the two electrodes. Okay, and again, you have high voltage. You can use RF, you can use microwave or whatever, but then again, it needs to require that you have a high voltage, which requires around certain kilovolt. Okay, so once you connect, or once you provide the high voltage to the setup, definitely it will be able to generate the plasma. Okay, so this is from the old days. I mean, if you talk about plasma, you know that is the fourth state of matter. You know how to generate the plasma is to have a setup that you're able to form the plasma itself. Okay, now there's a constraint with this situation. I mean, there's a constraint with the setup itself. I mean, the limit of the application, I mean, the application would be very limited. You see, when you want to deal with more or less like the applications in the hospital, I mean, the sterilizations, or if let's say you want to treat a sample, so it will be very difficult. So in that case, after that, after the formation of the fundamental setup of the DVD, so they come out with a new improvement. Okay, so they come out with a new improvement of the setup itself, whereby this setup is called non-equilibrium atmospheric pressure plasma jet. Okay, I mean, the motive for the aim is more to produce the plasma. Still, you want to produce the plasma, but somehow, how are you going to control in terms of the sample that you are using? Because if you compare, let's say if you want to treat a sample, okay, or if you want to do a treatment, okay, definitely it's not so convenient to have this kind of setup. Okay, unless it is actually more like a sampling which is not involved with living creatures or living things. Okay, but with this kind of setup, with this plasma, it's called plasma jet because you are able to blow out, you are able to push out the plasma. Okay, as you can see from here, this is the plasma jet. It will be more like purplish color. Okay, so again, as you notice from here, you have the electrode. Of course, you have the electrode, and then still you have the power supply, and also with the help of gases. Okay, so various research, they work with different types of gases. They try with so many types of gases. Either you have oxygen, you have argon, or you have helium. Okay, and at the moment we are also working with without the use of the external gas itself. I mean, if let's say you work with air, the ambient air. Okay, so as your working gas. Okay, so now the importance is just to ensure that you have a very convenient kind of setup, whereby it's able to be portable one. Okay, so here what I would like to highlight here is just to ensure that, I mean, just to tell you that if let's say you want to generate a plasma, definitely you need to know the fundamental part of the plasma. I mean, the fundamental setup in terms of what are the requirements, what are the apparatus that is needed in order to generate the plasma itself. And again, of course, they have different setup, and the current one, again, it depends on the applications that you are actually having. Okay, so as you can see from here, it says that the plasma is confined to the gap between the electrodes. The use of conventional DVD setup in biomedical applications has remained limited in a way that the sample itself. I mean, if let's say you want to treat a person's body, definitely you cannot put the body of the person inside that chamber, right? So of course they need to have new improvement. Okay, so that's what they have the plasma jet itself. Okay, so these situations change when investigators reported that with proper design, the plasma can be blown out of the discharge can and into the ambient air. So hopefully you have the idea of what is the plasma, how to generate the plasma, and also the configuration setup of the plasma itself. Okay, now we move on to the, as I said, I'm not going to talk about more technical part, but then more or less a sharing session on how this low temperature plasma has been applied from until today. I mean, from previously until today. Okay, so these are some of the applications that I would like to highlight. Okay, so again, whatever fields that you have, whatever fields, whether you are in medical school, whether you are in agriculture, food, antibacterial, sterilization, or whatever application, definitely I believe you can actually make full utilization of this low temperature plasma. Okay, now we move on to the medical part. Okay, as this one is more or less a history. Okay, just to give some idea when it is started, which means that it's not only limited to the medical itself. Okay, maybe after this sharing session, hopefully it will trigger some idea of, okay, maybe this plasma can be collaborated with another sample, not only the medical, so that we have new improvement to the field itself. Okay, so it will actually started in the early of 90s. Okay, so whereby they started with the decontamination of surfaces and media. I mean, in terms of the sterilization. Okay, and at the end of the start of 2000. Okay, so they actually applied the plasma jet. Okay, because the implementation of the plasma jet is more or less like convenient in a way that it's very movable. It's easy to be applied when it involves what do you call that? It's more on the medical part, like the wound healing process, the sterilization. Okay, and from here also they work a lot. I mean, in terms of the current issue, whether they are actually moving with trying to see the effect of the plasma, the low temperature plasma on the wound healing process in terms of the cancer treatment. Okay, so here just to share some part lah. Okay, so that's what we have so far. I mean, this one is not too current, not too latest, but then somehow we'll see that they actually work on various treatment. Okay, in medical side they have in terms of more or less like for the cancer treatment. Okay, how do we control? I mean, in a way that we know that it's low temperature plasma, definitely it will be safe to be handled. Definitely it will be safe to be applied on human being. Why? Because the temperature is low. I mean, it reached the temperature of the normal temperature. It will be around 26. It depends on the type of plasma that you are actually using. So definitely the first step to apply your plasma, I mean your system to whatever sample, as long as it's a living sample, definitely you have to consider about the temperature of the system itself, the temperature of the plasma itself. And then other than that, I did not actually include in the slides here, but somehow again there are few characteristics that you have to know, in not only the temperature but also in terms of the current involved, because we are dealing with discharge. So when we deal with discharge, so we have to ensure that it's not only safe to be exposed to the patient, I mean to be exposed to the sample, but somehow in a way that it won't be able to the patient won't get any current injected to the patient itself. So hopefully it will be very, very safe. Okay, so of course this is one part of some of the application that I showed here. I mean, it's not only on the wound healing process and not only on the cancer treatment, they also involve with various very, very tiny applications. Okay, not only straight away to the wound processes only. Okay, and other than that, as I said, it also involved with antibacterial. It can work as antibacterial, meaning if you happen to see like in the market, they also have this kind of ozonizer. Okay, we use this ozonizer to ensure that the environment or the air is sterilized. Okay, so the apart from, they have different what do you call that, the processes. So again, as you have ozone as part of the product, or the not the product, the contents of the species of the plasma itself. Okay, but then here, as we talk about antibacterial, again more on the mechanism. Okay, so what is the mysterious part of this our sharing session for today? Definitely this mechanism of antibacterial thing is still remain mysterious. I mean, still we are not able to explain in details, in terms of, still there is some unknowns that we are not able to explain, okay, in terms of the mechanism itself. But somehow when you talk about mechanism, definitely it depends on the species that have been produced, the species that have been generated by the plasma itself. Sorry. Okay, so all these species, they are actually plays their own role in terms of killing the bacteria, okay, or the sterilization of the bacteria. Okay, so from here, as you can see from here, it involve more or less like the breaking, it involve the ionization, excitation, it involve the breaking of the chemical bonds, erosion due to bombardment by radicals, okay, and also involve lesions and perforations in the membrane, and towards the end it will produce the apoptosis. So basically, again, the mechanism is still in ongoing processes, okay, but somehow it depends on the species that actually been generated by the plasma system that we have. Okay, so apart from the medical, also it involves in the sterilization, the antibacterial. Of course, you have a lot of research that actually work on this antibacterial activity. Okay, and not only that, okay, we have also interested with food industry. Okay, the food industry, whereby you need to know, because when we deal with crops, or when we deal with all this sanitization thing, okay, so of course we have to ensure that what will happen to the, or more or less like the more or less like the sterilization process, just in order to ensure that the food that we are preparing is actually safe, okay, to be consumed. Okay, and again, instead of that, also they have deal with, I mean, not only the direct expose, they can also have indirect expose. Okay, indirect expose means the direct, like the water directly exposed to plasma discharge, which means that you have plasma liquid discharge, okay, whereby that liquid is actually exposed to the plasma, and that liquid will be used to actually sanitize, or to actually sterilize the all the foods that we have, of more or less like the fruits. Okay, and whatever it is, it needs to ensure that you have safe certain dose that you have to ensure. Basically, in order different kind of appliances, we are dealing with different kind of dosage. Okay, now not only that, okay, people also work with agricultural, like some researcher previously they work with chicken. I mean, they plan to enhance the taste of the chicken. I'm not really sure how does the taste of the chicken will looks like. I mean, will taste after that, but somehow, hopefully, will this plasma treatment hopefully it will create something new taste. Okay, and again, here you can see it various applications in terms of the agriculture. Also, again, more or less, it's in terms of the more on the pesticide side, because if you look thoroughly into each of the field, definitely we will have different problems that may arise. Okay, but whatever it is, these plasma system, more or less, the purpose is so that you are able to kill the bacteria and able to increase the crop at the same time. Okay, so now before I come to the end of this sharing session, so I have few things to show here. Okay, now currently this is the current research that have been investigated, whereby they use this low temperature plasma, okay, in producing in the pharmaceutical field. Okay, whereby this paper here, one of the paper I shared here, okay, it review the research advances on low temperature plasma, okay, in enhancing or inhibiting drug activity. It is combined use with drugs to treat cancer, and its effect on the improvement of drug delivery system. Okay, so again, These would be, I would call, the current plasma research that, again, year by year, of course, the application would be more and more. Okay, and not to forget, this would be our current issue, which is the COVID-19. So they are actually dealing with, what do you call it? This one is more or less not a direct treatment. I mean, before you go to class, you don't need to sanitize your hand with the plasma, right? Okay, so they have one approach. Okay, whereby here they have this COVID-19, whereby they can CAP activated media, means they treat the sample. I mean, in this case, it's the fluid, whereby this fluid is actually used as the sterilizing agent or disinfection. So that, as you can see from here, this this technology can also avoid the need for sanitizers that require consumables such as alcohols and others susceptible to supply chain disruption, which means, again, it's a good improvement. I mean, it's a good research that I believe more and more research should be done in order to overcome this, not really to overcome, but to ensure that we are actually more or less like able to help in a way for this COVID-19 pandemic. Okay, so I believe that would be it for me. So hopefully, more or less, you have the idea of, at least if it's not too many, but at least you have something so for today. Okay, so with that, thank you. Sorry, I have one more. Okay, sorry. Basically, this is a closure. Okay, and again, hopefully you enjoyed today's session, and thank you very much.
Thank you so much to Dr. Nurhayati for your sharing session. Okay, regarding on plasma. Okay, again, I hope that audience, okay, the sharing session will give your basic knowledge and you can got some of idea, okay, regarding to this nanomaterial and also the plasma, and you can use, okay, or if you're interested, okay, for this the material in your further study or your research, okay, it can help you to get some idea and knowledge. Okay, I hope that today's webinar, okay, today's webinar will give you why we have had about this part. Okay, actually, physics is very wide. Just on because of so all speakers information and